So I am doing optimization. So whenever we're doing optimization, first we have to start with a sketch, because a sketch will always help us through the problem itself. So this one is a rectangular page is to contain 30 square inches of print, right? The margins are 1 inch. Find the dimensions of the page such that the least amount of paper is used. So what we know, it's going to look like this. So we have a page, and inside that page we have a print. This print is 30 inches squared, okay? And this is X, and this is 1, because the margins are 1, sorry. This is 1, but we know that this is X, and this is Y. This is 1, okay? All the margins are 1. Okay, so what we have given, we have that the area is 30 inches squared, 30 square inches, and then we know that the side is this is X plus 2, because 1 plus 1 is 2, and then you have X in the middle, and this is Y plus 2. So we know that area is equal to, area of this is equal to X, Y, okay, we know that. We know that the area of the entire paper would be X plus 2, this one side, times Y plus 2, okay, so we know that. Now, when we're doing these, we need to simplify down to one variable. So we have this, we're going to use this as our secondary equation to plug it in here. So if we use this, we know that A is 30, so 30 divided by X would be equal to Y, okay? So now we can take this and plug it in for Y. So A is equal to X plus 2 times 30 over X plus 2. 30 over X plus 2. Okay, so we have all X's now, and now we are going to find the derivative. Now when we find the derivative, it'll be easier to maybe multiply it out, because then we won't have to go through product rule and stuff like that. So we're going to say that A is equal to 30 plus 2x plus 60 over x plus 4. So that would be A would be equal to 34 plus 2x plus 60 over x. So now that we know that, we can find the derivative pretty easy. So the derivative of A would be equal to 2 plus 60 over x squared. Okay, so now that we know this, we're going to set this equal to 0 so that we can find the maxes or mins, whatever it may be. So we know that 60 over x squared would be equal to negative 2. And then if we divide by 60, then we can so like if we did this 1 over x squared times 60, okay, instead of having that, we know that when we divide by 60, 1 over x squared would be equal to negative 2 over 60, which is negative 1 over 30. Okay, and then we know that x squared would be 30 to square it. It could be positive or negative when we do that. Okay, so we know that could be positive or negative square root of 30. What we do is to check the maxes or mins, we have to plug it back in into the derivative to see where it is negative and positive. So let's say we had negative square root of 30, sorry, and square root of 30. We're going to plug in numbers in the middle, or in the n, back into the derivative to find where it's negative, positive, or negative. So when a max goes from positive to negative, it's a maximum. When a number goes from negative to positive, it's a minimum. So then when you check it, you're going to see which one is the minimum, and that would be your x value. So that is just one part of it. So we know what x is. So now we have to go take x, plug it back into the equation, and find our y value, and that's how you would find the dimensions for the least amount of paper.